One question that I had was around the chiplets. When they become so specialized, there's a risk, of course, that they become obsolete because things move on, right? So if we were to have now a chiplet for RNNs, they wouldn't be that important commercially. And with that, I see potentially a risk for a tremendous amount of e-waste or the concentration of the specialized companies that can manufacture them, right? Is that something that plays a part in the big picture as well?
Can you say the last part with the risk of our specialization? What comes?
Oh, the manufacturers of these chiplets. There's probably just a limited number of companies in the world that can actually create them and design them and manufacture them at a large scale, which of course concentrates vertically who can actually create them at the scale that is needed, which is of course a risk in itself because it reduces the amount of generic compute that we collectively have access to.
Yeah. So that's part of what we're trying to do. So there are two parts of the answer to that question. So I'm going to go back to Professor Carloni's talk where he demonstrated how students at the academic level could tape out chips using advanced technologies in an agile way. So we are in the era of agile hardware design. So what I see is that today designing digital circuits is not as difficult as it used to be. So I can see a place where many companies can, and that's what I was talking about with the marketplace. So we were talking about this chiplets marketplace, and that's part of what we're looking at as part of the Open Compute project. Where if I design a chiplet, which is not necessarily terribly difficult, I can put it in the marketplace, and if you are designing a different product and find my chiplet useful, you can just go and get it at a way reduced price because all the non-recurrent engineering cost is amortized among the many chiplets. The question for this is, we need to make sure that these chiplets work together, among many other questions. But and the majority of the work around it is on physical interfaces, UCIe and a bunch of wires. But part of the work we're doing in the work stream is here. Yeah, what part of the work we're doing in the work stream is going up a level, and the physical interfaces are figured out. There are a bunch of standards that will enable, at the physical level, chips to work. But above that, if I look at the application and the implications of accessing memory and the different algorithms we would have to run, what do we need to do for that to happen? So I think on the contrary, we have something like the Open Compute project and the chiplets marketplace that will open up the hardware design economy, which tends to be closed just because of the ADE tools that tend to be very expensive. So I think we're getting there if we keep going in that direction.
Any other question? I have one in the meantime. Earlier, someone asked about the vulnerabilities that can be introduced in certain novel architectures. I think it was in the Southern presentation. When you work with open source in software, well, you can patch here and there. Is that the same approach into open source hardware, or we should have a defined set of standardized secure things? How much do we have that covered in RISC-V?
Yeah, I think that's definitely a risk. As part of I don't work in security, so that's definitely out of my. But as part of the chiplets sub-project, there is a systems work stream that is actively looking into security. And remember, like this doesn't necessarily need to be open source hardware. If I have a chiplet and I produce it, you can go and buy it for me, and it doesn't necessarily mean that it's open source. You're paying for that. It's just that you're paying a lower cost of producing a whole chiplet. It can also be open source, right? Like there is no. But there are people, I mean, that's a big concern in the community. There are people actively looking into it. And if you are curious about what is happening in the community, I think the OCP work stream, the OCP systems work stream has a lot of people figuring out how to deal with security in a chipletized architecture in an open economy, the chipless marketplace.
And with that, join me thanking Patricia for a fantastic talk.